right, good morning, everybody. Good morning. So we've already looked at some nomenclature in the last video, and today we're going to look at some nomenclature. So now we see that we don't just have the regular metals. Um, we have some regular metals present. We also have some transition metals present, and I also see some polyatomic ions. Um, these are binary. These are not binary. This has a polyatomic ion. This one has hydrogen. So I know he's going to give off hydrogens in solution. So this one would be an acid. So we're going to take a look at the several different types of ionic bonding situations that we might come up with. All right, so for this first one, I noticed that there's a metal present. There's also a non-metal present. So I know this is ionic. I'm going to look to see, is this a transition metal? Just to make sure this is not a transition metal, this is an alkali earth metal. So this is this is the easiest one. I like it when there's just a regular metal, regular non-metal, because this is the easy naming system. Metal stays the same, last name gets IDE, and I think about this like the wedding scenario where your first name stays the same and you only change your last name. So I would name this one calcium oxide. Oxygen gets the IDE and oxide. So this would be calcium oxide. All right, on this one, I noticed that some of the students, they look at the numbers, and when we're dealing with transition metals, yes, we do need to use Roman numerals, but this is a non-transition metal. So although there are numbers at the bottom, I don't have to use Roman numerals or anything. So if I see a regular metal, regular non-metal, I'm always going to use the same naming system, whether I see subscriptions or not. So this one has subscripts on it. So it's still going to be the same system, though. So the first name stays the same, just like when we get married, last name changes. So nitrogen, he's going to get the IDE ending. So nitrogen becomes nitride. Just like that. All right, so now I come over here. I'm looking at this one. I want to make sure, I know Mr. Cantor is going to make it a little bit tricky, not much, just a little bit, but I want students to be able to distinguish that the difference between these. These elements look very similar. This is Ca, this is Cu. You might want to just write copper nitrate or nitrite, nitrate, IDE, nitride, copper nitride. But I want you to know that we have to check and see. This is a transition metal, so he's in the middle. If a transition metal is present, I have to use Roman numerals to indicate the charge. So the first thing I need to do is find the charge. So as I'm looking at my steps, I'm using the notes. So writing the chemical formula. Step one, I want to identify the electrical charge. So that's always going to be the first step. So here, we're going to identify the electrical charge. If I don't see any numbers, that means this metal has the same charge as this non-metal. So if I look on my labeled periodic table, make sure you have your labeled periodic table. This would be a 3 minus. There's no subscripts present, so that means they had balanced charge. The only reason I would see subscripts is if they need to balance the charge. If there's no subscripts, that means the charge was already balanced. Okay, and so still the same naming method. First name stays the same, last name gets IDE, so this is copper. But when I'm dealing with transitions, I know I'm going to have to use Roman numerals. Copper nitride gets the IDE ending. And so now I just need to look at the charge on copper to find out the Roman numeral. This is a 3+, so this is copper 3. Here, a common mistake that some students make, they'll see numbers and think that this is a different copper. All right, so now that I see subscripts, I have to use the reverse cross method. I'm still looking at the notes. So if ion numbers are different, we're using the cross method. All right, so I'm going to be using the cross method. So I want to check my non-metal just to be on the safe side, 2 minus. Okay, oxygen will always be 2 minus. He doesn't change. This is 3 plus. So then now first name stays the same, just like in marriage. I know I have to get a Roman numeral because we have transition. Oxygen becomes oxide. And so this will be Roman numeral number 3 because this is a 3 positive charge. So sometimes I might see subscripts, I might not see subscripts. That doesn't determine the identity of the transition metal. What determines his identity is his charge. So here, another common misunderstanding is this one looks very much like this one. So I might say, well, this is copper 3. This must be copper 3 oxide, but we can't do that. We have to follow the steps. So first step is to look to see if there are subscripts. There's no subscripts present, so that means this has the same charge as this one. So if I look on my labeled periodic table, that's 2 minus. So that means this one has the same exact ion number, positive, but it's positive, it's 2. So here, first name stays the same, copper. Now I see that we have a 2 plus charge. So this is copper 2, and then oxygen becomes oxide. All right, and then now we're looking at some of the acids and some of the polyatomic ions. So these are pretty much the same way. So now I'm going to be using my chart. So here, the chart tells me to name them based on the number of oxygens that they've lost or gained or have not lost or gained. So I'm going to be looking at this chart, and this will tell me the polyatomics. So the first one we're going to deal with is NO3. So I'm going to look on this chart and figure out where is that located at. All right, so it's the first one, nitrate. Okay, that's easy. That's an easy. So NO3. I also want to make sure he's an ion. That's going to be different from if I see no ion number up there. So this is nitrate. Okay, here I'm looking at, okay, how did this one change from the root polyatomic ion? Originally, he was nitrate. Here, he lost 1 oxygen. So let's see what to do if we lose 1 oxygen. So I'm going to go to my chart. If I lose 1 oxygen, I get the ITE ending. So nitrate will become nitrite. So now this is nitrite. Here we gained 1 oxygen. So when I look on the chart, gaining an oxygen, you get the per prefix and the ATE ending. This is going to be pernitrate. Here I see that nitrate has been balanced with hydrogen. This has a 1 minus. We have 1 hydrogen present, so I know that this is an acid. Acids are defined by being able to release hydrogen ions in solution. So this is going to want to dump off that hydrogen. This is an acid. So I named that one. Acids get the ICEN, nitric. So here we can see that if I've balanced it out with the correct number of hydrogens, it's going to get the IC ending. So sulfuric acid. Here, this is the original one, SO4. So I'm going to look on this one. SO4 is here in the chart. So that sulfate is the original polyatomic ion. So I'll call this one sulfate. Here, I noticed that he's been balanced out with hydrogens. So I'm going to call this sulfuric acid. Sulfuric acid has a very pungent odor, like sulfur. Here, I noticed that this isn't a binary ionic, but this is calcium with a 2 plus. This is SO4 with a 2 minus. So these are, this is an ionic bond. I can see my polyatomic ion there. And so now it's an ionic bond. Okay, same thing. First name stays the same, calcium. And then this one is sulfate. I won't use the IDE ending because this is a polyatomic ion. So he'll just keep his name sulfate. So calcium sulfate. All right. And then next we're going to be looking at writing the names from the chemical formula. That video will come up next.